Welcome everyone. In today's lecture, we will be talking about the sections of solids. It's chapter number 13 in our textbook. The sections basically mean we want to look inside the object. So it is on your screen you can see a typical cutting plane has been passed through an object, and we are going into the details inside. So here our learning objectives are, so we learn different types of concepts, what different nomenclature we have for sections, section planes, sectional views, true sections, etc. And we'll also learn about what is the procedure to be followed, so to obtain the sectional view from the geometrical solids. And we'll also try to understand what are the typical sections for different geometrical solids, so that we have to deal with. You can see about the nomenclature, what do we mean by section and the section plane. So section plane is kind of a cutting plane. We assume that our object is been cut by a plane, and then we view the object. So it is represented by a chained line, and at the ends we have a thick line. But in our course, the practice is we shall use a green colored line to represent the section plane. So we have color coding, so that color coding we can follow. So the rest of the color coding remains the same, only that the section plane, so that will be represented by the green color. So then the hidden lines, etc. So many times, so within a section plane, within the section view, so we don't show hidden lines, or within actually the section we do not show the hidden lines. In rest of the object in the section view, so we can show the hidden lines, or we need to show the hidden lines. So typically, let us say we have a cylinder here. So in this cylinder, if the section plane is AA, and that section plane AA has been shown in the side view as well as in the top view. It's basically a vertical plane, an additional vertical plane or a plane parallel to the vertical plane passing through the axis of the solid. So that solid or that section plane leads us to the section view as shown. So it gives a rectangular section with the length equal to the height of the cylinder, and the width equal to the diameter of the cylinder. So if the section plane is somewhere else, let us say passing through this position, then you will get a little smaller section plane. All right. So this is how in three-dimensional view the earlier section plane will appear. Now the terminology that I have just already used, but let me clearly define here. Section, by section we mean the portion which is hatched here. It is shown by hatching. So the portion which appears after cutting, that is called section. It is represented by the inclined lines at 45 degree, but simply we have to hatch it, and that hatch pattern at 45 degree lines, that is easily available, so that we have to insert. And the plane of cutting, it is called the section plane. I already emphasized on that. In some of the situations, as I explained earlier, let us say the section passes through, section plane passes through this point. In that case, the solid may look like this one, where the section will appear only partly like this. So then there is a difference. So this is called the section, and this whole thing is called the sectioned front view or sectioned view. This is called the sectioned view. so or sectional view. Okay, so this is the terminology we shall be mainly exploiting, and you can see, so this is another section plane. So here where we have a hollow object, so in case we have the hollow portion, so there we don't show any hatching, and it's very helpful in visualizing complex shapes, and when the inside details otherwise are very difficult to comprehend through hidden lines, because there may be hidden lines due to several of the features. So if only certain section about that the information is to be conveyed, so then the sectional views are very useful. Like in this case, from the top or from the front view, from outside you cannot judge how the details are there about the surface, but through the section plane, so the things are, or through the section view, the things are much visible. Now about the section planes, the positions of the section plane, we have to understand the nomenclature about the positions of the section plane also. So first thing we have to understand that generally the section plane will be perpendicular. It will be perpendicular almost always. So it will be perpendicular to at least one of the plane of projection, maybe VP, maybe HP, or maybe the profile plane. So it can be, that is why the plane, it's actually a plane and which can be defined by the trace. So in the previous case also we have shown the section plane with the help of a line. So how we are able to show it with the help of a line itself? The reason is, so the plane is perpendicular plane and its trace is a line, or through its trace it can be easily identified. So for some of the planes you have the trace on VP, and or you can say you only have a vertical trace. For some of the planes you have only the horizontal trace. The planes which have horizontal trace, they are definitely perpendicular to HP, and they are called auxiliary vertical planes because they are perpendicular to HP. And here we have a number of auxiliary vertical planes. You can see this plane is, in the second case, this is an additional vertical plane, plane parallel to the vertical plane. This is called auxiliary vertical plane. This plane is parallel to the HP, so this is called auxiliary horizontal plane. This plane also is perpendicular to VP, it's perpendicular to HP, okay, so and it's perpendicular to VP also, but still it can be called as auxiliary vertical plane. So this is also auxiliary vertical plane. So this one is also auxiliary vertical plane, and when the plane is perpendicular to VP, then it is called, so when it is perpendicular to VP but inclined to HP, you can see that this plane is also perpendicular to VP. This is called AHP, but this plane can no longer be called AHP because it is not a horizontal plane, it's an inclined plane, so its nomenclature is AIP. So these are typical nomenclatures we can use. In addition, you must understand that whenever the planes are cut by two different sections, two different section planes, when solid object is cut by two different section planes, the hatching portion due to one cutting plane and hatching portion due to the other cutting plane, that must be distinguished. So for example, if I have, let us say, a sphere, so which has been cut like this and which has been cut like this. So I am cutting the sphere using two different section planes. So then in the top view in the other view, okay, so it must be represented by a different hatch, like in one half it must be in other direction, in another half it must be in other direction. That is what so we have shown here. So if it is cut by the same section plane, then everywhere the hatching must be same. These are the guidelines we have to follow. Now we take a few model solutions So one very simple one we will take first. A square pyramid, base edge 125, height 150, is standing on its base on ground with the two base edges parallel to VP. So two base edges parallel to VP that and standing on the base on the ground, that means it's a top view, you will see the base. Okay, so it will be like this. So the base edges are parallel to the VP. So this is how it will look like, correct? So this is how, so I have drawn the initial position, and here because it's not the plane axis or base is not inclined, so this is the final position itself. Here we are more bothered about locating the section plane also. So locating the section plane is also very important. Note that in the present case it is cut by an AIP, auxiliary inclined plane. That means it will be a plane perpendicular to VP. So it will be visible as a line in the front view. That is what we have shown here. So auxiliary inclined plane. So it's basically a horizontal plane at an inclination. Okay, so auxiliary inclined plane making an angle of 35 degree, passing through a point on the axis 60 mm down the apex. So what we can draw from here, the 60 mm we can draw, and then from here, so we can draw a line at 35 degree to the ground. So that is the first step you have to carry out. Now after carrying out this step, you have to now show in the top view how the section, you have to show the sectional top view. Basically section will appear in the top view, so you have to show that. How will you show that? You need to transfer the points. So now from here you will use the transfer of points method again. So these points will give you different points in the top view. So how will you get them? So from here you draw the vertical, okay, and you know that this point is on O dash A dash, also on O dash B dash. So OA and OB, they are located here, and so the points on OA and OB are located. Similar way, so from here you draw the vertical, and you know that this point, it is lying on O dash C dash and O dash D dash. So on OC and on OD in the top view, so we locate the points. So this way we get 4 points. So now these 4 points, they are to be so these 4 points they have been shown here also. So they are shown, and finally so they are joined together, and the portion which in this case section planes, what we do, we assume that there is very important assumption that the portion which comes between the section plane and the observer, that is assumed to be removed. So this portion which is enclosed here, so that portion is assumed to be removed. Note that in the front here where the section plane is located as a line, so there the portion is actually not removed, but it is assumed to be removed. And in the other view where the section will appear, so there it has to be actually removed. So you can see here, so all these this portion of the slant edges, so it has been removed in the top view. So this is how it will look like, and finally you do the hatching. So that is it. So this is as simple as this. So you get the sectioned top view. You may ask, what is the true shape of the section? So here, though it is not asked, what you need to do if you need the true shape of the section, so simply this portion or this VT you make horizontal, or what you will need to do, you will rotate this whole thing to make the plane horizontal. Okay, so you can either do this by measuring the angle here, this angle you can measure, and by that amount you can rotate this whole thing you can copy here and you can rotate, and let us say this point and this point, so they are coming up here. Then for the true shape what you will do, so from here and from here you draw the verticals, and finally from here and here and from here and from here you draw the horizontals and you join them together, and this way you get the true shape. This is the true shape of the section, and true shape again we need to hatch. So this is the concept about the true shape. How the true shape is obtained? So simply, so this portion so has been copied here and that has been made horizontal. So this is one type of problem. So we have again a problem defined. Let us read the statement first, so without the diagram. So here, so we again have a square pyramid, but in this case your base diagonal is given. You are not given the side, you are given the base diagonal, and you are given the height. It is standing on its base on the ground with all four base edges equally inclined to VP. So equally inclined, it means your equally inclined to VP, that means in the top view it will appear like this. Okay, so because this way the inclination of all base edges is equal to VP. So in the top view, if base edges they are equally inclined to HP, that means it is inclined to VP only. If they are inclined to XY line, so that means it is inclination with VP. It is cut by an AVP, auxiliary vertical plane. So here it's a pyramid. So first we start with the top view, which contains the shape, true shape of the base, and finally so we are given the height. Based on the height, so we know how much deep we have to go, and we can locate its front view. This way, so we can reach the first step. So here you are told that the AVP passes through it. So it is cut by an AVP, which makes an inclination of 35 degree to VP. So that 35 degree inclination will be shown in the top view. That means this plane is to be shown in the top view, and passing through a point on the closest slant edge. Note that the closest slant edge is here. So how I can say this is the closest? You can see, so typically you are in the third quadrant and you are having, so let us say this is the top view. So if this is the top view, then the edge closest, because you are observing from here in the third quadrant, you are observing like this. So then this is the edge closest to you. Okay, so if this is the edge closest to you at a top view distance of 25, that means in the top view we have to measure 25. It's not the actual distance or the distance along this edge, along this slant edge. It is the distance which is visible in the top view, or apparent distance. Top view, in the top view is 25. So from that point on the nearest slant edge, this point passes, this particular plane cuts the slant edge. Draw the section view. So location of the section view is very important here. So we have to locate that first. So at 25 mm from O along this edge, we have to pass the line at 35 degree, and then we have to transfer the points. So we located the section plane, now we have to transfer the points. How you transfer the points? You have this point to be transferred, you have this point to be transferred, then you have this point to be transferred, and you have this point. So this way you have 4 points to be transferred. For this point, which is the last one, so BC, let us transfer this first. So BC is it is on BC in the top view, so it will be on B dash C dash in the front view. That is how you locate it, directly you transfer. Now other thing is on OB. So this point which is on OB, it is on O dash B dash, but OB and O dash B dash, they are collinear. So even if you draw a line as in the previous case, you don't reach any specific point. So you need something different. What you need? So what you need here is, from here, you remember the point which was used for cutting plane method. So cutting plane method, we went parallel to the base. So we went parallel to this base and we cut a point here. Okay. So this point is on OA. So we locate that point on OA. Okay. So this is a meaningless point here, but it from here, so horizontally if we go, so we reach our desired point. So two different points finally we obtain. This point is meaningless. This is meaningless. This is not needed. This is only an intermediate point. Okay. So now this point is the one which we transferred. This point is the one which we transferred. This one and this one we already transferred. About the point here, so that is on OA, so that can be directly transferred. So no problem at all. Then we have another point here on AD, which is behind. AD is on the rear portion. Note that if it is behind, it has cut the slant edge from here. So note that this slant edge will no longer remain in the sectioned view. Okay. But anyway, so here we are just transferring the points. First you get the transfer of point from, which is on O, which is on AD. So this point we transfer here on AD in the front view, or A dash D dash in the front view. So this is how we get. Now due to as I explained earlier, so this portion of the slant edge, this portion of the slant edge, okay, so this portion is assumed to, this whole portion actually is assumed to be removed. Now this portion includes this base, okay, so that means here this portion will go away. So how it will show up? So in this step I have not shown it to be removed. So here I have just connected the points because so this point is connected with this point. So first this point is used, then this was the first point, let us say this is the second point, this is the third point, and here no sorry, so here I have point number 1, here I have point number 2, here I have point number 3, and I have point number 4. So 1 2 3 4, first they are joined together, and then comes the question of cutting down. So this edge will go. So in the next case this edge has gone, even this edge, so that has been removed. So because I already explained, so this portion, whole thing has gone. So this is how we complete the drawing. Okay, so sectioned view I got. If the true shape I want to get, what I will do, so I will take this thing, okay, so as it is, and I shall make it horizontal. So how I will do that? So because it is at 35 degree, so I will rotate it by 35 degree, it will become horizontal, and from there, so different points I'll already be having. So from those points I'll drop the verticals, and the corresponding points from here I shall again draw. So this way, so somewhere an approximate thing, let us say if I draw, it will show up something like this. Okay. So, the true shape also can be obtained in any of the section view problem. So, this was another type of problem where we had the section plane located in the top view. In the first case, section plane was located in the front view. Here section plane was in the second problem, section plane was located in the top view. In the third problem, we have two section planes. You can see hexagonal pyramid having base edge 100 mm and height 255 mm is standing on its base on ground with its opposite base edges parallel to VP. So, you can see how opposite base edges parallel to VP I have shown, and it is cut by two AIPs. One AIP is parallel to the ground and another AIP is inclined at 60 degree to the ground as shown in the figure. So, they have been shown directly. Okay. So, if this way the section planes are shown, how they are to be, how they will yield the section view. So, that through the transfer of points you can obtain. You can see this is on OA. So, you will get the point here, and a similar way this point is on OB, and this is also on OF because it is 2 points here. So, it is on 2 points here, and due to that reason, so here also I will get and here also I will get. So, 2 points I obtain. This way, so several points I can obtain, and for the point which is on the face, on the slant face. So, how do I get this point? So, what I will do, I will draw an imaginary slant edge, and corresponding slant edge I can draw here also and here also, and on that I can transfer the points. That is how I will get the points here. Now, another point is on this edge, so that also by drawing a vertical I can obtain. Okay. So, and finally this point. So, that way also I can get different points like this, and then I need to understand that here we have two section planes. Due to that, they are to be shown by a separate hatch. So, they need to be separated. You know that you note here that I have drawn a line also in between, wherever the two section planes were meeting, I have drawn a line here. So, that has to be shown, and this portion which is showing number of slant edges. So, this portion, because it is assumed to be removed, this portion is assumed to be removed. So, in the next point I have trimmed all these lines, and finally the sectioned view, sectioned top view has been shown here. So, this is how, so the problems related to the sections of solids, so they are solved in a systematic manner. So, there are a few more problems available where the solution is discussed on AutoCAD. So, they will also be quite useful for you, you go through them. Now, regarding some typical true shapes. So, we must understand that whenever, because sometimes the problem may be given in a reverse format also. You may be told that the true shape looks like this, or the sectioned view looks like this. You decide how the section or where the section plane passes through. So, in that case you need to be familiar with some of the typical shapes. For example, the sections of a cylinder, if we talk about, when you cut horizontally a cylinder, you get of course a circle as the sectioned view. When you cut the cylinder by an inclined line, the sectioned view will be circle. Okay, but the true shape, if you talk about the true shape will be the ellipse. Okay, section view will be still a circle, even if the cylinder is cut by an inclined line, the if you view it from the top only, it will still look like a circle, but if you view it from top, it will still look like a circle, but if you view it in the perpendicular direction, so that you get the true shape will be the ellipse. The cylinder, when it is cut by a vertical line, you get a rectangle. Okay, so this is about the cylinder. So about the sphere, if the sphere is cut like this, you will get a circle. If the sphere is cut by an inclined line, the apparent shape will be ellipse, but the true shape will be circle. So it has been clearly marked here. So about the cone will give you circle when cut by a horizontal line, and you can get a triangle from the cone only if it passes through the apex. This is very important point. If from a cone you want to get a triangle section, you can be successful only if the section plane passes through the apex. And if this way the cone is cut, you will get the ellipse. If the cone is cut like this as shown here, so then you will get the parabola, and the hyperbola is when the cone is cut by a vertical plane like this. So these are some of the typical section planes. Another view of the parabola or the isosceles or triangle. So you can also get the equilateral triangle in some situations. Some possibilities are there that this and this side, if they are equal, so then it will lead to an equilateral triangle. So some situation may arise. Sometimes it is possible, some other times it may not be possible to get the isosceles triangle from the section of the cone. The hyperbola, another view has been shown. The ellipse from the cone has also been shown in another view. So this is what we have in the case of cylinder also. So the ellipse that will be resulting by a section plane has been demonstrated. So a cone, when it is cut with a vertical plane, so it is, let us say, cut by a vertical plane, you get a hyperbola like this. If the cone is cut from here, then you get the triangle. You can get a triangle from a cone. It has already been explained in another set of videos that the cone, it will give you the triangle only if the cutting plane passes through the apex. So that kind of model unfortunately I do not have at present. So that can also be visualized. So with this, I think you will get a good understanding. So this is what will help you to initiate the sections of solids. There are some other more difficult problems that you can refer to different videos also available, and you can try. They are left to you also, so that you can develop your imagination skill. So with this, it is hoped that you will be able to take up the problems with confidence. So thank you.